Hello and welcome. I'm David Martínez and I'm part of the development team of the Snowpark Checkpoints, a powerful tool to detect different functional equivalence problems when migrating into Snowpark. In today's presentation, we want to introduce how to use this framework and also how to interact with it by using the VS Code extension for Snowflake. But first, we're going to have a brief overview of our migration process. Then we're going to see how to use this framework and the main idea behind it. And finally, a little demo to show you how to interact with the framework by using the VS Code extension for Snowflake. As part of our migration process, we need to transform different code bases into Snowpark. To do that, we already have the Snowpark Migration Accelerator. It is a powerful tool to migrate Spark code bases into Snowpark. And also we can assess the client's code. But we need to be completely sure that our behavior in Snowpark is the same as we had in PySpark or Spark. So are we completely sure that we're getting the same functional equivalence now in Snowpark than we had in PySpark? If we want to analyze critical paths of our code, can we attest that we preserve the same functional equivalence? To answer or address those problems, we developed the Snowpark Checkpoints Framework. The idea behind this framework is to collect metadata from PySpark and then collect metadata from Snowpark. Remember that we already have our code migrated into Snowpark by using the schema. Now that I got my metadata from PySpark and Snowpark, we can make different comparisons over these metadata to see if we preserve the same consistency over the schemas and the data from the data frames that we want to analyze. So here we introduce the concept of checkpoint. What is a checkpoint? A checkpoint basically is a function call where I can indicate if I want to collect metadata from a specific data. So in this code snippet from PySpark, we have our data frame definition. And imagine that I want to collect metadata to make different validations once I migrate into Snowpark. In this case, I call the function collect data from checkpoint. And I send as a parameter the data frame that I want to analyze or retrieve metadata from and a unique name for the checkpoint. Then in my Snowpark code, I want to get metadata from that data frame and also compare with the metadata that I previously collected from PySpark. To do that, I define my data frame and then I call the function validate data frame checkpoint. And I send as a parameter the data frame, the identifier that I assigned previously in my PySpark code, and finally the job context from PySpark to make the different comparisons over the schema. This is a diagram of the main flow of the framework. First of all, our entry point will be the PySpark code. If we want to collect metadata from different data frames, I can use the schema mode. The schema mode generates JSON files with the metadata from the schemas that I wanted to analyze. So for every checkpoint defined in my PySpark code, a JSON file will be generated, and it contains all the metadata related to that data frame. And if I want to use the data frame mode, it will generate different Parquet files. These ones will be uploaded into Snowflake. So it means that I will have the same data stored into my Snowflake database. It uses the CLI connection defined on your machine. And the results are the different Parquet files. Then imagine that we already have our code in Snowpark migrated by using the schema. We can use both modes that we saw previously for PySpark. If we use the schema mode, it will retrieve the metadata from the JSON files, and also it will create different JSON files from the data frames in Snowpark and make the different comparisons over the schemas. And then we have the data frame mode. It will retrieve the data stored into Snowflake and also make different comparisons or validations over the data itself. And finally, the different results are written into the output folder to make them accessible to the client. Now, let's have a quick demo to show you how to interact with this framework by using the VS Code extension for Snowflake. Hello, and welcome back. Here in our VS Code environment, we'll find a new tab in our Snowflake extension called Snowpark Checkpoints. This one contains the different checkpoints defined across our workspace. If you click on one of these tabs, you'll find the different checkpoints defined into the Python file, and also the line number where it was defined. If you double-click this number, you'll jump into its definition. If you want to add a checkpoint, you can use the context menu and click in the Snowpark Checkpoints option, and you can add a collection or validation checkpoint. It will add the function placeholder and also its required parameters. In my case, I already defined different checkpoints, so I want to use this option. If you want to run a collector individually, you can use the code lens and click over Run Collector. It will open the output channel for Snowflake and also use your Python environment defined for the VS Code. Sometimes we need to authenticate depending on our CLI connection. And as you can see, the command was successfully executed. And there is a results table. It shows the different results when collecting metadata from that data frame. If you want to run all the checkpoints from this file, you can use this button from the navigation bar. As you can see, there are the results when running every of these checkpoints defined into my Python file. There are different information related to checkpoints, such as the file where it was defined, the checkpoint name, remember this is a unique identifier, the timestamp when it was executed, the line of code, and the result when running the checkpoints. This is the workspace structure of my project. We have a PySpark project, and as you can imagine, this is the original code base, and also the Snowpark project. This is the project we got after migrating by using the schema. And this is a folder to store the different results. As you can see, a JSON file was created for every checkpoint defined in my Python file. And these files store different metadata related to the data frame. And also we have a file for results related to the different checkpoints defined into the Python file that I ran. In this file, we have several checkpoints defined with the data frame mode. We saw that this mode enables the loading of Parquet files into Snowflake. So we're going to have that data frame stored into Snowflake to make different validations then. I'm going to run all the checkpoints defined into this file with the data frame mode. As you can see, all the checkpoints were run successfully. And also in our output folder, we have two different folders for every checkpoint defined. And here we have different Parquet files. Now, a table will be created into your Snowflake database that you previously defined for your CLI connection with every checkpoint. So for every checkpoint defined in your Python files and run in the data frame mode, a table will be created into Snowflake with the data from data. Now, if we want to validate, we can just define a validator in our Snowpark code. And for example, we can run all the validators defined into our Snowpark file. Something important to mention is that if you don't specify a mode for your validators or collectors, the schema mode will be used as the default option. And as you can see, our validation was successful. It means that we preserve the same equivalence in our schemas in Snowpark and also in PySpark. And also we can see the validation using the data from mode. So it will use the data from already stored into Snowflake and make different comparisons over the data. So I'm gonna run all these checkpoints defined into this Snowpark file and just wait to retrieve the data from Snowflake. As you can see, the different validations defined into this Snowpark file were successful, and that's pretty cool. Here in my Snowpark file, I have different validations, such as check with the Spark, or this one, check output schema. Those are different decorators that we can use to capture, for example, the result from a function or capture the schema from a data frame sent as a parameter to a function, and also make different validations over those user-defined functions in Python to check if we preserve the same behavior now in Snowpark than we had in PySpark. So you can learn more about these different decorators in our documentation. Finally, we can make different bulk operations over our checkpoints. For example, I'm gonna open these checkpoints.json file from our PySpark project, and if we, for example, toggle these checkpoints, they were marked as disabled. And also, as you can see, their status is changed in the checkpoints file. Also, if you want to remove them all, you can clear all the checkpoints from this file. If you want to see, again, the different results from running the checkpoints, you can just look for the command show all Snowpark checkpoints results. And it will show you the different results from running those checkpoints defined in our files across the workspace. And also, we can see a timeline related to the execution of the checkpoints. This timeline uses historical data, so you can see if across the time a checkpoint result changed, and you can detect, for example, if it was related, for example, to an update from a library or something. So this is pretty cool to keep the tracking of our functional equivalences across our workspace. That's pretty much how to use this framework with the VS Code extension. I hope this helps you a lot to detect different problems when migrated into Snowpark. Thank you.